Good day, evening students. This is Part C, MYA Review, Equations of Parallel and Perpendicular Lines. So right now you should be pulling up your long-term memory review in your OneNote class notebook, and you're pulling up MYA Review Part C. Also, you should be going to quizzes and pulling up the MYA Review Part C there as well as your assignment. Right now you're going to follow through with me as I go through the lesson with you while you have quizzes up. All right, so we are reviewing parallel and perpendicular lines and the equations of those lines. So remember, parallel lines are two lines that have equal slopes. So as you can see here in the picture, we have the two lines moving in the same direction. Okay, they are equally distanced apart from each other. And we also notice that in both equations of the lines, their slopes are the same. So both of these lines are in what we call slope-intercept form. We see M here represents our slope, and we see that our slope for both of these lines are 2. Perpendicular lines. So we see that perpendicular lines do not have the same slope. They actually have a negative, or as I like to say, opposite reciprocals. So you see the slope for the green line, they show it as being -6/7, and then the opposite reciprocal of that slope would be just to flip the fraction, so 7/6, and then change the sign to positive. So now we would have +7/6. So when dealing with these types of equations, we always have to look at the slope to determine if it's positive or negative. But sometimes they give us 2 points. And as you can see, to find the slope of 2 points, we take the 2 points that are given and plug it into our slope formula. So our slope formula says that we use the rise of a run, where our rise is y2 minus y1, and our run is x2 minus x1. So we just take the points that we have here and our 2 points that are given, plug them in based on the order that we see, and then that would give us our slope. Okay, so we already talked about the slope-intercept form a little bit, but as you can see, the slope-intercept form is y equals mx plus b, where we have here m as our slope and b as our y-intercept. And this is normally the form that you would see a linear equation in. So you should be going to quizzes right now, or still should be in quizzes. And now the next slide that you're going to see is some practice with parallel and perpendicular lines in regards to their slopes. So look at this first question and see if you can work it out on your own. And then once you've worked it out on your own, you can come back and watch to see if you got it correct. All right, so now that you're back, let's look at this question. Determine whether each pair of equations are parallel, perpendicular, or neither. So first, I have to determine what form are these equations in. So I see equation number 1 is already in slope-intercept form, and remember, slope-intercept form is y equals mx plus b, where we're focusing on m, which is our slope. So I see here equation number 1, I can easily identify the slope as being 1. Remember, there's another little imaginary 1 right here. So the slope of the first one is 1. Number 2, equation number 2 is not quite in slope-intercept form, but we can solve for y to make it in that form by dividing everything by 4. So dividing everything by 4 gives us y equals, remember, that's 1/4 x plus 3/4. So the slope of that line is 1/4. So looking at these two slopes, I know that these two slopes are not equal to each other. Parallel, I don't see that they're not equal to each other, so they're not parallel. Perpendicular, well, perpendicular means that I have opposite reciprocals. 1 is positive and 4 is positive, so that they can't be opposite, so they're not parallel. So the correct answer for this one will obviously have to be neither. All right, looking at the second question, again, go ahead and pause the video right now to see if you're able to work this out on your own, and then come back to check yourself. All right, welcome back. And the next question says, are the lines L1 and L2 passing through the given pairs of points parallel, perpendicular, or neither? So once again, if I'm looking at 2 points that are given to me and I want to determine if they're parallel or perpendicular, I need to look at their slopes. And remember, the slope formula was y2 minus y1. over x2 minus x1, and we use this formula for a given 2 points. So let's start with line 1. Line 1 we can label as x1, y1, x2, y2, and just plug it in. So y2 is 1, y1 is 3, x2 is 3, and x1 is 0. So we have 1 minus 3 gives me negative 2. 3 minus 0 gives me 3. So I know the slope of line 1 is negative 2/3. So that's our slope for the first line. Now let's look at line 2. And we're going to do the same. Label our points. So y2 is negative 5. y1 is 4. x2 is negative 7. And x1 is a negative 1. So we just go ahead and simplify. Negative 5 minus 4 gives me a negative 9. We have a negative and a negative here that automatically makes that a positive. So I have negative 7 plus 1 gives me a negative 6. And a negative gives me a positive, so I know this is going to be a positive answer. But I can also reduce this by dividing by a common factor that both 9 and 6 have, which is 3. So if I divide 9 by 3, I'm going to get 3. And then dividing 6 by 3 gives me 2. So I know the slope of this second pair of points is 3, 2. Okay, so looking at these two slopes, I know they're not equal. I have a negative 2/3 here and a positive 3/2 here, so they clearly are not parallel. But we can look at them and determine if they're maybe perpendicular. Well, looking at them, perpendicular means that I have opposite reciprocals. Well, I have opposite signs. This one here over here is negative 2/3, so that's a negative, and this one over here is positive 3/2. And then I also have the fraction 2/3 flipped to 3/2. To be sure though, remember perpendicular means that they have the product, the slopes have the product equal to negative 1. So if I take negative 2/3 and I multiply that to 3/2, I should get negative 1. And if I do, I can guarantee that it is perpendicular. The slopes are perpendicular, or the lines are perpendicular. So negative 2 times 3 gives me a negative 6. 3 times 2 gives me 6. Negative 6 divided by 6 gives me a negative 1. And as I can see, these two pairs of points would give me two lines that are in fact perpendicular. All right, looking at the next question, once again, go ahead and try it on your own, pause the video, and then come back to see if you got it right. All right, so welcome back, and the question says determine which lines, if any, are parallel or perpendicular. So we're looking at these three lines that are given and determining the slope of the lines, and then determining if one, two, or all three are in fact parallel or perpendicular. So with this first line, y equals 3/5 x plus 1, I see that it's already in slope-intercept form, so I can easily identify the slope as being 3/5. So that was pretty straightforward and easy to do. The second line I see is not quite in slope-intercept form, but I can do some manipulation to make it into slope-intercept form by dividing by 5. So when I divide by 5, I actually get y equals 3/5 x minus 2/5, and that gives me the slope of 3/5. So far we have two lines, the same slope. This last line, though, is not in slope-intercept form, so we have to do quite a bit more work. So the first thing we have to do is solve for y, and we can do that by subtracting 10x on both sides. So that, in fact, leaves me with negative 6y equals negative 10x minus 4. We're going to go ahead and solve for y by dividing everything by a negative 6. So when I divide by that negative 6, I am left with y equals negative, and a negative gives me a positive. So that's a positive 10 over 6, x, not y, x. And then negative over a negative gives me a positive, so that's going to be 4 over 6. Both of these fractions, 10 over 6 and 4 over 6, I can reduce by dividing by 2. So that will leave me 2 goes into 10 5 times, 2 goes into 6 3 times, so I have 5/3 x here, and then 2 goes into 4 2 times 2 goes into 6 3 times. So I can identify my slope as being 5/3 for this last line. So as I can see, I have the first 2 lines with the same slope, and this last line is kind of familiar, but it's flipped, but there's no opposite, so we can automatically eliminate this one. So I can say the first line and the second line have the same slope, and if they have the same slope, I can conclude that these 2 lines must be parallel. Okay, so when we're talking about parallel and perpendicular lines and their equations, we can also use another form, which is called the point-slope form. Most times we use this form when we are given the slope of one of the lines and we're given a set of points. If we're given those set of points and that slope, we can clearly plug it into the the point-slope form. Here, m is our slope, and then we have x1 and y1 as the set of points that we're given. And we also talked about another form. We kind of saw the other form, which is the standard form of a linear equation, where we have constants, a, b, and c that are given, where we have x and y on one side, and we have the c on the other side, and a is always positive. So you might see equations in this form as well when we're talking about parallel and perpendicular lines. All right, so take this time to look at this question, writing the point-slope form of an equation of a line as described below. You can pause the video and then come back to see if you were on the right track. Okay guys, welcome back. The question says write the point-slope form of the equation of the line described. So remember, the point-slope form is y minus y1 equals m times the quantity of x minus x1. So we're going to take the information that was given to us. They gave us a point, -1, 4, so that's my x1, y1. And they gave me the equation of the line y equals -5x plus 2. I see that this is in slope-intercept form, so I can easily identify the slope as being -5. So this is the equation of the first line. I need to find a second line that's parallel to this first line. So remember, parallel lines means that they have equal slopes. Okay, so I'm going to use the slope of -5 and the point that's given to me and plug it into the point-slope form. So we already have it written up there. So y minus y1, we already know is 4, equals m, which is our slope, which is -5, times the quantity of x, and minus x1, which is -1. So let's clean this up here. We have 2 negatives, so that becomes a positive. So our equation is going to be y minus 4 equals a -5 times the quantity of x plus 1. And we're going to leave our equation in this form because the question said to write it in point-slope form. I see that this is the correct equation because I see here that my slope is the same here, and we know that parallel lines have equal slopes. All right, so once again, we have another equation, another problem. Go ahead and pause the video to see if you can work this one on your own. All right, so write the slope-intercept form of the equation of the line described. So remember, the slope-intercept form is y equals mx plus b, where m is the slope and b is the intercept, the y-intercept. So they gave us the line going through point 4, 3, so that's my x1, y1. And then they said that the equation is parallel to, so we know it's going to be equal slopes. It's parallel to this equation x equals 0. So that's my first equation. I need to find the second one. So let's look at this equation x equals 0. If we recall from Algebra 1, x equals 0 is actually the x-axis. So the x-axis is the horizontal axis here. So the x equals 0 line is here. And I want a line, an equation of a line that's going to be parallel to that. That's going through point 4, 3. So let's identify where 4, 3 is. So let's put some markings here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 4, 3 will be 4 units to the right and 3 units up. So we're looking at 4, 3 somewhere around here. So remember, this line, this second line, has to go through this point 4, 3. So if the line is going through 4, 3 and parallel to the x-axis, that means my line would have to be horizontal as well. Okay, so I see I have two lines here that are parallel, and they are equally distanced apart. But now we have to figure out what this second equation is going to be. So if my line is going through this point on the y-axis, this point is 0, 3, that means that my equation of the line has to be y equals whatever point it's going through, which is 3. So the second equation is y equals 3. All right, so let's look at this next equation or this next problem. Once again, go ahead and pause the video to see if you can work out this problem on your own. All right, welcome back, guys. So this problem says write the point slope form of the equation of the line described. So remember again, the point slope form is y minus y1 equals m times the quantity of x minus x1. So they give us the point 4, -4, so that's my x1, y1. And this time, it's going to be perpendicular to the equation y equals -x minus 4. So remember, perpendicular means it has a product. The slopes have a product equal to -1, and they are going to be opposite reciprocals. Okay, the slopes are going to be opposite reciprocals. So equation number 1, I can easily identify the slope because it's in slope-intercept form. So my m is going to be -1. But that's not the slope that I'm actually going to use to find the second equation. Remember, the slope has to be perpendicular to the original slope. So how do I find that? Well, the product of the two slopes have to be -1, and they have to be opposite reciprocals. So if I have a -1 as my original slope, the opposite reciprocal, or the negative reciprocal of the original, would be a +1. So the slope that I would use for my second line would actually, in fact, be 1. And I can see that that's true because if I take -1 and multiply that by 1, I get -1, and that's exactly what we need. So I'm going to take my slope, I'm going to take my point and plug it into the point slope form. So y minus y1, we already know, is -4. Equals m, remember, we're using 1, times the quantity of x minus x1, which is 4. So we can clean this up on the left. Negative and negative gives me a positive. So y plus 4 equals, if I distribute my 1 to everything, I have x minus 4. So the equation of the line in point slope form of my second equation is y plus 4 equals x minus 4. All right, so looking at the last problem in this section, once again, go ahead and pause the video to see if you can work it out on your own. All right, guys, so we're back, and it says here that we are writing the equation now in standard form of the equation of the line. So remember, standard form is ax plus by equals c, where a is always positive, and a, b, and c are just numbers. So they give us the point that it goes through, which is 3, 1, so that's my x1, y1. Once again, perpendicular to, so I know the product of the two slopes is going to equal -1, and they're going to be opposite reciprocals. And then the equation of my first line is y equals -2/3 x plus 4. So once again, my equation is in slope-intercept form, so I'm easily able to identify my slope of the line, which is -2/3. But remember, the slope of the second line has to be the opposite reciprocal. So the slope that I really need to use is opposite of negative, which is positive, and then the reciprocal of 2/3 is 3/2. So the slope I really need to use is this, 3/2. How do I know for sure that this is correct? Well, if I take the product of both of these slopes, -2 times 3 gives me -6, 3 times 2 gives me 6. I see that the product gives me -1 is exactly what I need. So first, because they gave us a point and a slope, we're going to use the point slope form. Okay, so I'm going to take my point slope form and plug everything in. So y minus y1, which is 1, equals m, which is 3/2, times x minus x1, which is 3. So everything looks pretty good here. We don't have to clean anything up, so we continue. Y minus 1 equals, and I'm going to distribute 3/2 to everything, so 3/2 x minus 3/2 times negative 3 gives me a negative 9/2. And then I'm going to add 1 to everything. So let's bring that back over here. So y equals 3/2 x, and I have negative 9/2 plus 1. So let's do some of that over here. Negative 9/2 plus 1 is really saying 2/2. Okay, I can't add unless my denominators are the same, so I converted my 1 to reflect the denominator. That's the same with 9/2. So 2/2 is the same thing as 1. So now I can add across. Negative 9 plus 2 gives me a negative 7. And then we just bring the denominator over. So I have y equals 3/2 x minus 7/2, right? But it said here that I want to write it in standard form. But before we write it in standard form, I want to make sure that I have the right slope. And I see that I do here. 3/2 is the right slope that I need. So I can continue. So I want to write this in standard form. If I write this in standard form, I see, my numbers have to be whole numbers or integers. And I see that I'm working with fractions here. So I want to get rid of these fractions. To get rid of these fractions, I'm going to multiply everything by the common denominator, which is 2. So if I multiply everything by 2, I get 2y equals 2 times 3 is 6. 6 divided by 2 is 3. And then 2 times 7 is 14. 14 divided by 2 is 7. So now I have some nice looking numbers here. Okay? Now I'm going to move my 3x to the left because in my standard form, my x and my y are on the same side. So when I do that, we're going to move over here again. I have negative 3x plus 2y equals negative 7. But remember, a is always positive. So that means I'm going to multiply everything by negative 1 to get rid of that negative from my a. So that means I now have 3x minus 2y equals positive 7. And there you go, ladies and gentlemen. That is my second equation written in standard form. Okay, guys, so that concludes our review on quizzes. You need now to go to your long-term memory review in your OneNote class notebook and go to the MYA Review Part C where it says Even Day. And you're going to work out the 6 problems that you see there. I will post the answers for those 6 problems probably later on today or tomorrow, so that way you're able to check to see if you were correct and see your mistakes. All right, guys, so I will see you, I believe, next week, Monday, and have a wonderful day, guys.